morning and a warm welcome to the final day of the ECMWF Summer of Weather Code 2021. We are very happy that you join us today for this virtual event, which has two parts. We will present you all the project outcomes of the ECMWF Summer of Weather Code in the morning. We will present you 5 projects, and we also have a part 2 in the afternoon where we present you another 4 project results. If we could go to the next slide. So ECMWF Summer of Weather Code is an innovation program which brings together each summer mentors from ECMWF and Copernicus together with developer teams. And the mentors and the teams work together on open source developments related to meteorology, climate, machine learning, and web visualizations, for example. So ECMWF Summer of Weather Code is brought to you by ECMWF and the 2 Copernicus services, the Copernicus Climate Change Service and the Copernicus Atmosphere Monitoring Service. And it is also additionally supported by the 2 European cloud initiatives, the European Weather Cloud and the Copernicus DIAS service, Wikeo. And these 2 services provide ECMWF Summer of Weather Code cloud resources for data-intensive processing, for example. If we could go to the next slide. So ECMWF Summer of Weather Code has been has started in 2018, and in 2021, this year, we already had the 4th edition of the ECMWF Summer of Weather Code. The program itself starts always in springtime with the applications, and it works like this, that mentors, so project challenges are proposed by ECMWF and Copernicus mentors, and developers can then apply or submit their proposal to a specific challenge. So the final teams are then selected, and the coding phase is always going from beginning of May until end of August, where the open source developments take place. And the final showcase day, which is today, where we present all the great results and outcomes of the coding phase. If we go to the next slide. Yes, so this year we had 9 developer teams who worked during a 4 months of coding period on open source developments related to open data, machine learning, cloud computing, and web visualizations. And the next slide. So part 1, so the next 2 hours will showcase you 5 projects related to a ECMWF user dashboard, to machine learning examples, one more of an applied machine learning example, and the other one how a coding library, or like a library, a Python library to make machine learning for meteorological and climate data easier. And this library has been extended. And then also two examples on web visualizations and how to visualize meteorological data in a more compelling way. And then at the end, we have a Q&A session, and this is where you where you come into play. If we go to the next slide. So this is today also an opportunity for you to interact with the developer teams that were part of the ECMWF Summer of Weather Code this year. So please go to slido.com and enter the hashtag ESOC 2021. And this is your chance to ask questions about the projects, or also if you're interested about the project team's experience being part of ECMWF Summer of Weather Code. So this is your chance. So again, go to slido.com and enter the hashtag ESOC 2021. Before we start with presenting you the first project, I would like to invite Florian Pappenberger, who is the Director of Forecast at ECMWF, and who wants to give a short welcome from ECMWF. Good morning, Florian.
Thank you very much, Julia. It's going to be short. I have to say that this is one of the most exciting days every year, when the final projects of the European Summer of Weather Code are presented. The other one is a bit earlier when the first ideas come together. The European Summer Weather Code is I think, a really exciting project for us, a really exciting thing, because there's so many ideas coming up and so many solutions coming up which I've never have dreamt of or thought of. And it is no accident that behind me you see an exploding TARDIS, because I believe that's exactly what the Summer of Weather Code is doing or trying to achieve. I would like to say thank you to all the people who've organized, all the people who helped. So that's Julia, but many others too. To all the mentors at ECMWF who've given their time and worked hard together with others. And of course, to everybody of you who's actually done some work and really tried to do different examples. And I think if you listen today to all these talks this morning and this afternoon, there's a fantastic range of different talks and topics in that respect. And I can already see that first slides are coming up. Anyway, I don't want to hold this proceedings up for too long, because I think the exciting things will be the proof will be in the pudding. You will see the exciting talks. Thank you everybody. Thank you everybody for listening. And let's get amazed by what people have done. Thank you.
Thank you, Florian. And now I'm very happy to present you the first project, which has been developed by Varun Banker, who joins us today from India. And he worked on a project called ECMWF User Dashboard. And he worked together with ECMWF's user support section to develop a user dashboard. And I think he is much more expert or much more or better in explaining what he actually done in the project, and I'm already looking forward to seeing the results. So Varun, the floor is yours, and again a warm welcome also to you.
Thank you, Julia, for such warm introduction. Hello everyone. I hope everyone is doing great. I'm Varun Banker, a computer science student from BITS Pilani, India, and today I'm going to present you my project result. Next slide, please. Next slide. Yeah. This is the outline of our today's presentation. First, I'll talk a little about my project and the goal we wanted to achieve, and then I'll move on to the technical aspects of it. After that, I will talk about how the project is deployed and the challenges we face during development phase, as well as what we learned from them. Then we'll see a short demo of the project, and finally, I'll conclude with how this project can be extended. Next slide, please. When we started this project, we wanted to build a dashboard for users through which they can get a bird's eye view of their favorite service at ECMWF. We wanted to keep it modular so that it is extensible in a way that it is easier to incorporate more services further down the line. And lastly, we wanted it to be easy to maintain. Next slide, please. So what is this user dashboard? In short, it's a web application in which user can add widgets to get information about the services they use at ECMWF. They can organize it to their preferences, as well as they can share their dashboard with other users. Next slide. So let's quickly dive into the technical design of this project. We have a lot to cover here. Next slide. So initially, this was the high-level design of our project, in which we had Django at the backend acting as the proxy server, then PostgreSQL as the database, and Create React app in the front end. But as we developed the project, we soon realized that Django and SQL database are not the right choice for our needs. And we were constantly trying to re-implement workarounds to get the feature set we wanted. So we decided to change the tech stack midway of the project. Next slide. Next slide, please. Yeah. So this is the current design of the project, where we have Express.js server running inside Node.js, NoSQL database MongoDB, and Next.js in the front end. The front end is developed independently of the backend and communicates with the backend via REST APIs. Next slide. So let's have a closer look at the responsibilities of the backend. It manages many of the application essential services, such as server-side state management, user authentication, communicating with the database, and also communicating with various services of ECMWF, in which case it just acts as a proxy server. Next slide. For the database, we decided to go with NoSQL database rather than SQL database, which we had earlier, because there wasn't any need for relational database, as most of the data required for smooth functioning of the app could be modeled as a JSON-like document. This database stores the information about the user and the state of the dashboard, and it doesn't store any data fetched from ECMWF server, as it might get stale if cached in the database. Next slide, please. The front end uses React framework Next.js. It has a lot of pre-configured optimizations, and it can also generate static files, which we are currently using for this project. The static files are sent to client's browser, and any dynamic data is fetched from the backend via REST APIs. It is also responsible for rendering of all the tabs and widgets, as well as client-side state management, which is done locally using IndexedDB for faster renders. Next slide. The authentication is always a tricky part of any project. This project currently uses custom JWT implementation via Passport.js. So basically, when the user logs in with their credentials, the backend responds with a token, which is then saved in user's local storage, which is used with any subsequent request to the backend. But that is just one side of authentication, which is between the client and the server. What about between server and ECMWF services? This was resolved with the use of API tokens to access certain services of ECMWF, but not all services do support this mechanism. One downside of having custom authentication is that the user accounts are not mapped with user accounts of ECMWF. Next slide. Let's look at few core components. So this is the tab manager, which describes the complete structure of the dashboard. Given this tab manager, the front end can recreate any dashboard. Next slide. Here we have the tab component, which describes the content and the layout of a single tab, as well as the list of users with whom the tab is shared with. Next slide. So widget IDs are crucial for recreating the widgets, as they contain information about the type of widget, basically the builder class ID. And it also contains a unique ID, which helps to place the widget to its specific layout position. The widgets ID are also used with widget configurations, which basically is used to store any kind of data that might be required to recreate the widget. For example, the text widget might store the text content inside of the box. Next slide. Now that we have seen the tab manager and all of its components, let's look what happens when you interact with the dashboard. Whenever the user makes any change to the dashboard, it updates the state locally first and then makes an API request to the server to store the new dashboard state. Now, what if the user refreshes the dashboard? In that case, the dashboard tries to load its state from local storage, but if it fails, then it requires, it queries the backend for dashboard state of that user. Next slide. So at the backend, this is the user schema that is stored in the database, which contains general details about user, ECMWF API tokens, as well as our tab manager. Next slide. Because we are describing this dashboard state using one big JavaScript object, optimization techniques are important so that performance is not affected. We mainly do three things to optimize performance. First is to reduce network load by loading the dashboard state from local storage rather than server-side storage. Second optimization is done by memoizing any computationally heavy function, so they are not affected by state change unless they need to be recomputed. Third optimization is done by not updating the dashboard state if it's stale, which means if for some reason, there's a dashboard state waiting to be updated. The timestamp of that state is checked with the existing state, and it is only updated if the state is newer. Next slide. Now let's look at the deployment architecture and how understand how it is set up. Next slide. Currently, the project is packaged into Docker containers and deployed to on EWC Kubernetes cluster. There are 3 containers at the backend which communicate with each other. The whole deployment is complemented with GitHub Actions, which enable CI/CD capabilities. So whenever a developer pushes something to GitHub branch, the container would be rebuilt and redeployed without any further need of configuration. Next slide, please. On to the challenges encountered while developing this project and what we learned from them. Next slide. The main challenge of interfacing with ECMWF servers as a third-party service prevailed. But we did find a solution for it using the API tokens, which might very well be feasible for other services too. We also face challenges with authentication as previously stated. And lastly comes the question of security, and if ECMWF servers should allow to share data with this application, even though it's not storing any data and is deployed on EWC infrastructure. Next slide. While trying to solve each challenge, we did learn a great deal of information. We changed our tech stack to closely align with the requirement of the project. We implemented custom authentication and discovered new ways to interface with ECMWS services. We also learned different ways to store dashboard states in order to optimize render times. Next slide. So with most of the technical details covered, let's now look at the demo of the project.
Welcome to ECMWF user dashboard demo. Let's quickly check out the user dashboard. I can use it without logging in for certain widgets. But for best performance, it's better to log in so that my work will get saved and synced with the backend. So let's try to log in. You can fill out your credentials right here. If you don't have an account, you can register your account by clicking here and filling in your details and then clicking on continue, and a new account will be created for you. But as I am already registered, I'll just log in by filling in my username and my password, and after successfully logging in, I'll be rerouted to my dashboard, which is empty now. I can add multiple widgets from this drop down. There are a wide variety of widgets to choose from. I can also add charts by going to the chart browser. Here I can search for charts, turn on images to see the chart thumbnails. I can add multiple charts, so let's select these two. Then going back to dashboard, I can rearrange my charts, resize them to my liking, and I can also interact with them. Then I can also go into full screen mode. Now let's rename this tab to charts, so we know what kind of widgets are present in this tab. I can also add new tabs by clicking on this plus icon. I can add multiple tabs, and if I have to close a tab, then I can go to tab setting and close the tab. Let's rename this tab to status widgets. Now let's add some status widgets to this tab. Let's add this mask widget. You can see that the widget failed to load the data. That is because we haven't updated our tokens. You can get your API token from ECMWF. So I have my token here. I will copy it and update my tokens. I'll click save tokens and go back to dashboard. And now you can see the widget has loaded the data. Let's try to add more widgets. Let's add this satellite alerts widget. And let's add this web API widget. We can move and resize our widget to our liking. As well as we can remove the widget by clicking on the close button. We can also change tabs and the layout will be retained. Let's look at the share functionality of user dashboard. Let's share this tab with username foo. We'll get a link. Let's copy this link. And here I have logged in with foo's username. I'll paste the link here. And now Mr. Foo can look at the shared dashboard. Even though he can't move the widgets, he can interact with widgets by clicking on certain elements. Let's go back to our dashboard and look at the options we have in our profile. So you can change the password, you can clear tab manager, or you can log out. So when you log out, you will be redirected to the home page. So that's it for demo. Thank you for watching.
So that was the quick demo. I think we have a little time remaining, but let's quickly cover the extensibility of the project. Next slide. So from the start, the project kept a modular approach. It has a very interesting design where there are builders and which build the widgets using the widget blueprint. And it's all just 3-step process to add a new widget. Next slide. This is a simple block diagram explaining the process, but let's look at it in action through a quick demo. Next slide. If you could play the demo.
So now let's look at how easy it is to add a new widget to our dashboard. So we have 3 files open here, 2 of which are templates. This is the builder template, this is the blueprint template, and this is where we will define our new widget. So let's modify our builder template. So we have to add a unique class ID here, and we can modify the default layout, minimum width, minimum height, and the maximum height the widget can have. Then we will add the blueprint, and that's all for the builder template. And now we'll modify our blueprint template. So the blueprint is basically a valid React component, and to have a uniform look, it has a widget container and title bar. Let's modify our title here. And a lot of utility functions can be imported from tab manager context. Currently we are just importing one, which is to remove widget from current tab using the widget ID. And you can add any valid component between the widget body to define the look and feel of your widget. So we'll add a div component here for demo purposes. We'll save this and our new widget is done. So before we look at in our dashboard, we'll add it first to the configuration file. So we define it by builder class ID, and then we define its name and builder class. So we'll name it my awesome widget, and then we'll define the builder class. So we are done here. Let's look our new widget in our dashboard. So this is our previous dashboard. Let's look at the list, and we can see our new widget has been added to the list, and we can add our new widget to our dashboard. And even after a refresh, the new widget will stay there. Now let's look at Mr. Foo's dashboard. If we go to my account, you can see that this dashboard belongs to Mr. Foo, and even he can see the newly added widget in the shared dashboard.
So that's how we add a new widget. It's a very simple process. So I'd like to conclude my presentation here. Next slide. It was a great experience working on this project. The project is quite modular and can be extended easily. I would like to encourage people to try out the dashboard if they are interested, and even check out the repo. Next slide. The links can be found here. Next slide. Finally, I would like to thank my mentors, Helen, Sylvie, and Carsten, for guiding me throughout the project. They have been very helpful and very fun to work with. I also want to thank Edward for deploying the project to the cloud, and also Esperanza and Julia for their efforts in organizing everything. Thank you for your time. If you have any questions, you may ask.
Thank you, Varun, for presenting your impressive results and the great user dashboard you applied. We don't have so much time left for many questions. I would have a question. So do you know what are the future plans of your developments now?
Yeah, so there are many widgets that we can add. So a lot of ECMWF services can adapt for this user dashboard. So basically they can have a specific endpoint which shows only the data which a widget can consume. And then we can add a specific widget for that in the dashboard.
Okay, and eventually it will be also integrated into ECMWF's user support services?
Yes, I would think so. Yeah, it can be.
Okay, great. So it was a pleasure also to have you as part of ECMWF Summer of Weather Code 2021, Varun. So it's very impressive, your developments. I would like now to take the opportunity to welcome Het Shah and Avishri Kari, who also were part of or are part of ECMWF Summer of Weather Code this year, and who worked on a project called Machine Learning for Land. So they used Earth observation data, climate reanalysis, and machine learning to detect Earth heating patterns. So they, Het and Avishri are joining us today from India as well, and they collaborated with ECMWF's research department on this project. And Het and Avishri, a warm welcome, and we're looking forward to your presentation.
Thank you, Leah. This was very helpful. Hi, everyone. Thank you for providing us this opportunity to present our work here today. I am Avishri Khare, and I am here with Het Shah, and we would be talking about our ESOC project called ML for Land. We would first like to thank our amazing set of mentors from ECMWF for their constant support and guidance throughout our ESOC journey. Thank you, Esperanza, Julia, for the constant support as well. Okay, so let's get started. Next slide, please. Yeah, so this is the agenda for our presentation today. We'll start by motivating you about the problem that we are trying to solve, all the way through to what we actually achieved and where the project is headed to in the future. Next slide, please. Okay, so what is ML for Land? The core idea behind ML for Land is to understand important land surface cover characteristics. And the characteristic that we focus on here is the radiative skin temperature, commonly known as the land surface temperature, or LST in short. So why is LST important? The answer to that lies in recent research, which suggests that LST is heavily correlated with several other important physical phenomena, including land use patterns and heating patterns of the Earth. And so if we have a model that can accurately predict land surface temperature, that would also provide us valuable insights on these phenomena. And I'm sure most of us would love to see that. Next slide, please. Okay, so how does ML for Land do this? So we wish to build a model that can predict satellite variables by using input variables from the model world. So the satellite variable in our case was the land surface temperature that we get from the NASA MODIS satellite. And the input variables are ERA5 reanalysis variables, including 2-meter temperature, dew point temperature, total precipitation, and so on. The objective here is twofold. Firstly, we obviously wish to have a model that can very accurately predict land surface temperature. And we also want to see how this compares against existing models of LST. The model that we use for benchmarking is ERA5 reanalysis variable called skin temperature. And we wish to see how our model is better or worse compared to this ERA5 skin temperature. We also want to understand where ERA5 skin temperature is currently lacking and how that can be improved by using our model as a post-processing step. The second important objective is to find a consistent set of variables that can help in determining land surface temperature. If we have a consistent set, we are sure to head towards robustness, and that would also help us understand if our model is using the right physical intuition for making predictions of land surface temperature. So as you can see here, it's a very simple thing that a tool does. It takes in ERA5 input variables and attempts to output very accurate land surface temperature predictions. Next slide, please. Right. So here is the roadmap for our project. We have a 4-step process, the first 2 of which were completed before the mid-evaluation. And after the mid-evaluation, we focused on regional estimation. Here, instead of having individual sites or individual points for which we predict land surface temperature, we instead have large regions for which we wish to accurately predict land surface temperature. So the challenge here was to extend our model from being a point-wise model to also understanding characteristics of an entire region. The 4th step here, which is global estimation, is something that we wish to continue in the future as a part of this project. So this presentation would mostly be focusing on the regional estimation and the results that we got from that phase. Next slide, please. Okay, so here is the pipeline for regional estimation. We model this entire process as a regression problem, primarily because land surface temperature is a real valued variable, and we compare that against some models, ground truth land surface temperature values. There are 3 important components in this pipeline. We have the data, the model, and the metrics used for training the model. So let's start with the data. We consider 2 important regions here and 2 diverse regions indeed. The first region would be in and around United Kingdom, so roughly covering the entire United Kingdom. And the second region would be parts of Southern Europe and some parts of Northern Africa. For these 2 regions, we took the data from 2000 to 2021. And these are the ERA5 input variables that I was mentioning earlier. This data is divided into 2 sets. We take the years from 2000 to 2018 as the training set, and the years from 2019 to 2021 as the testing set. For the point estimation pipeline, we considered the months of February and August. However, for the regional estimation pipeline, we only looked at data from the month of February to understand how well our model can work for a given month. The second part of the pipeline is the model, which varies based on the learning algorithm used. We experimented with several ML algorithms, including linear regression, random forest, neural networks, and so on. And the final part of the pipeline was the metrics. We used mean squared error, where we compare our predicted land surface values, land surface temperature values, to the LST values that we get from the NASA MODIS satellite. We also have our benchmark, which is the ERA5 skin temperature values, and we see how well our model is performing as opposed to that. So the pipeline has an ML model which takes in some data and compares that with NASA MODIS data till it can churn out accurate LST predictions. I would now like to call Heth to continue with more details on our work.
Thank you, Avishri. So moving on, next slide, please. So as Avishri was mentioning for the past few slides, we take ERA5 reanalysis variables as our input points for our input data. So we consider two different sets of variables. So these variables would make up two different independent sets. Right? So the first set, we take two different sets of variables. So both of the sets are given over here on our screen. So the first set and second set have some common variables which are mentioned. So from TP to wind speed, there are some common variables which we include. And on top of that, we have some different sets of variables. So for the first set, there are T2M and D2M, which is the 2-meter temperature and 2-meter dew point temperature. And for the second set, we have RAD, which is the radiation from the Earth's surface, as an added variable which we consider. So there is a simple reason as to why we take these two different sets of variables. So the first set contains T2M and D2M, which are model outputs, which are directly influencing the skin temperature. So this is in a way sort of the model output, which is the skin temperature or land surface temperature. And it has been it's like a proxy to that particular data. And we don't always want that to be used in our model, because that is in a way sort of cheating for our model and sort of getting the output before actually trying to predict the output. And in set B, we have radiation, which is not a part of the model. So in this particular set, the model has to understand and come up with the predictions entirely on its own. So these are the two sets of variables which we sort of consider. Moving on for the next slide, we'll now begin to show results of our models, which Avishri was also talking about, and we'll show results on two regions. So the first one is the UK region, and the second one would be the Southern Europe and the Upper African region. So for the UK region, we come up with, so there are four sort of diagrams that you see on your screen. So on the top right is the MODIS LST data. So that is the ground truth data that we get from the NASA MODIS land surface temperature dataset. And on the bottom right, we see ERA5 skin temperature, which is again from the ERA5 dataset which we have. So you see there are some white regions in the NASA MODIS data. So the land surface temperature dataset is only available on the land part, as the name suggests. And it is also missing for the places where there are cloudy regions. So that's why the lower UK region is missing some data in that particular day. So it could be possible that in some other day that the data is available for that particular region. But for this particular day, it's missing because there was some cloud cover over that particular region in the UK. So coming to the results of our own model, so we have just shown one model for each set, which was the best performing model for us. So for the set A, we have this sort of diagram, and for the set B, we have this sort of predicted map. So we see that we get an improvement of around 2 Kelvin for both of the cases. So it's quite close. It's 2 Kelvin for both of the sets, and it's around 35% improvement on 35% improvement against ERA5. So one thing to note is that we are using random forest model for both of these sets to predict our outputs. So, and again, now we see what are the top 5 variables, because this is what will determine what is going on inside the random forest model. And we see that some set of variables are common between both of the sets for the prediction, and T2 and D2M is getting replaced by RAD. So this actually shows, and this is like physically also explainable as to why these variables are affecting the prediction of land surface temperature more. So moving on to the next slide, we perform a similar sort of an experiment here again for the Southern Europe region. And we again see better performance compared to the ERF5 skin temperature. So we see around 1 Kelvin improvement for set A and 0.6 Kelvin improvement for set B. So this turns around 21% and 13% respectively for set A and set B. So some more interesting things to note from these set of experiments is our models, our random forest models, are able to capture the heating patterns of Africa in a way better manner than what ERF5 is actually seeing. So you are seeing yellow patches over here in our predictions, which is sort of missing in the ERF5 skin temperature region. And the variables again are coming out to be consistent for both the sets. So next slide, please. So there were some challenges also that we faced along while performing this sort of experiments. So the first one was trusting the LST values that we get from the NASA MODIS dataset. So in the first UK experiment, we were getting around 6 RMSE score for the ERF5 SKD temperature. So it was puzzling to us that why we were getting such high RMSE score. So what we did was we took only the good quality data using the quality check flag on the MODIS LST dataset, and we sort of reduced our dataset because we are now only considering the good quality dataset. So now we saw around 23% improvement in the RMSE score for ERF5 skin temperature. But again, this was not changing the performance of our model, so which shows that our models are robust to these good quality or bad quality data, and it actually shows how effective our models are in this particular case. The second challenge was scaling. So right now we showed results on 2 smaller regions again from the European region. And this is not actually entire global scale. So scaling is still an issue for us. So that's why we are only considering smaller heterogeneous regions of Europe as of now, but we do plan to scale it to global region, global or continental regions in the future. And the third challenge is ERF5 is an hourly dataset. Like it gives you values for each and every hour, whereas MODIS is for a daily basis, and also sometimes the data is missing for some regions, like due to cloudy cover or due to bad quality data and stuff like that. So this is again a challenge, and we are trying to impute or aggregate values or trying to use neighboring values to impute the values which are missing and sort of giving us more data in that way. Next slide, please. So finally, we conclude and give an outline as to what we plan to do next. So to conclude, our models, machine learning models, are able to understand patterns in the data set, in the data that we are trying to provide, and are also being robust in the sense that it is robust to the bad quality data and fluctuations which are getting predicted in the data set itself. And a consistent set of variables are turning up as the most important features for predicting the LST values. And these values are physically explainable to what could be the values. And as a future work, as even Avishri has talked about, we would like to extend it to a global scale and continental scale, and sort of experiment with neural networks which capture local spatial relationships between different points which are there, which we haven't done till now. So this is it from our side. Thank you so much for having us.
Thank you, Avishri, and thank you, Hit. It was great. Thank you for your presentation and very impressive results of your project. I have a question regarding, you showed the results now for the random forest outcomes. But at the beginning, you said that you actually also want to compare different machine learning models. Did you also already implement different models and you chose random forest? Or this would be now one of the next steps, as you pointed out in the future work, that you would like to also investigate more into neural networks with spatial dependencies? So for now, we have experimented with some of the models which Avishri has talked about, like logistic regression, decision trees and stuff. But
random forest was the best performing model for us till now. So that is what we have shown the results as of now. And we would be sort of experimenting more with neural networks in the upcoming days. So that is the plan as of now.
Okay. And what challenges do you see when you now want to go to a global scale?
The biggest challenge would be that of memory, because we don't have enough memory on conventional systems to handle data of that scale. And what we then have to do is to shift to better machines. So far we were only working on local machines, and we would definitely love to take advantage of the Veka Cloud credits that are offered. And we'll also be using several batching techniques so that we reduce the amount of data that is present in the memory at a given instance of time. So we'll have to just look at how efficiently we can churn out data from the storage to the RAM. And that seems to be the only concern here.
Okay. And so I understood you will continue working together with your ESOC mentors even after today.
Yes.
Yeah. Okay. So that's already great to hear. And again, it was great, or it is great to have you as part of ECMWF Summer of Weather Code this year. And thanks again for your presentation today and for being with us today.
Thank you so much.
Thank you so much.
I would like to now go to the next project, which also has a machine learning focus, but more on making machine learning easier, specifically with weather and climate data. And there is a Python library currently being developed at ECMWF with the name CliMetLab. And one project which has been developed or supported by Ashwin Samudre investigated how this Python library can be extended. And this is now the next presentation, which will be given by Ashwin Samudre, who is joining us today as well from India. And he will tell us more how about his work on extending CliMetLab, the Python library for machine learning for weather and climate data. Welcome, Ashwin. It's great to have you here. The floor is yours.
Thank you, Yulia. So yes, I'm Ashwin. I'm currently a master's student at Simon Fraser University in Canada. And this year I mainly worked on adding a few features to CliMetLab, which is a package currently being developed at ECMWF, mainly by Bodo and Florian, my mentors. And I worked with them during this 3 months, and I've tried adding a few functionalities in terms of drivers and plugins, which I'll be presenting now. Next slide, please. So firstly, to give you an overview of how the CliMetLab is managed and how it's currently being developed, the library is still in very early stages. So there are four main functionalities that we can talk about. So first is data access. We can get there are multiple climate and meteorological data sets which need to be handled properly. So CliMetLab tries to give proper data access to these data sets. Then the next factor is processing of these data sets. So we need to have proper data processing. Then the format handling, we have multiple data formats like NetCDF, GRIB, and all these formats. And to handle all these formats in one library, it is currently being employed here. Then the loading of this data, it's also inculcated here. The next factor is interoperability. CliMetLab plans to provide different, so it's being developed with the view of being helpful for machine learning projects. So in machine learning community, Jupyter Notebooks and this machine learning frameworks such as TensorFlow, Keras, PyTorch are highly used. And CliMetLab plans to provide best of both. So it acts as a bridge between when you can take the data sets for your climate and meteorological data sets and plug them, you load them, and then try to train the models with this SciPy stack and this machine learning frameworks. So you can just import these frameworks into CliMetLab and use them with the data that you have loaded. And once you have trained this model, you need to, and you get the outputs, you need to have good interpretation of this output. So we also plan to add this output interpretation functionalities, which is different graphs and curves that we get during the training of the models. CliMetLab is mainly built with this plugin architecture, which is easy addition of data sources, data sets, and plotting styles. So that's what one of this is like. One part of my project was this addition of Intake plugin, which was really helpful due to having this very flexible plugin architecture. Next slide, please. Okay, so to give you an overview of this year's my work. So previously I presented the overview of CliMetLab, but now I'm presenting what I tried to do as part of adding features to CliMetLab. So I mainly worked with two things. First is the plugins part, where we focused on providing simplified data access, which we tried to do with Intake library. And the other part is adding drivers. So to have, we currently have Magix as the go-to package in most of the ECMWF software suite for plotting purposes, since it works very well with geographical plots. But for machine learning specific plotting, we tried to go with Matplotlib. So this was mainly the two tasks that I tried to work on this year. Next slide, please. Okay, so the project goals. First one, Intake is to give you an insight of what exactly I'm talking about. The Intake library is. Intake is mainly a lightweight set of tools which helps in loading and sharing data primarily in data science projects. We wanted to extend CliMetLab so that it seamlessly interfaces with Intake, and it allows users for all the Intake compatible data sets. And the second goal was to extend CliMetLab so that we can offer user with high-level Matplotlib-based plotting functions. This can be helpful, as I mentioned, to produce the graphs and the plots that we get when we are training machine learning models. And this could be specific to the applications that we're planning, is specific to the weather and climate data sets. The curves and plots can be plume plots, ROC curves, training and loss curves, these and many more. So next slide, please. Okay, good. Moving on to implementation details. So for the first task, when we are dealing with Intake plugin, so the Intake mainly provides, it has this advantage that data sets can be described in catalog files. When we are dealing with weather and climate data sets, we have most of the data in terms of which can be described in catalog files, and that's why it's really important. We are able to load that data with as user-friendly as possible, and that's why we went with Intake. And currently the package is released on PyPy, and it's as simple as importing any other package in Python. So currently what can be done is you import CliMetLab and then you load data, and instead of you having to write this Intake things, the plugin takes care of that, and it calls the Intake open dataset call. So it also handles the data dependent things. And we are currently supporting the following file formats, which are CSV, netcdf, SAR, GRIB, and Pickle. These are mainly keeping in mind that we are going for machine learning based projects. So these are the primary file formats that we come across, and that's why we are focused on this. Next slide, please. Here you can see I've released this first version of CliMetLab Intake plugin, and this is currently ready to use, and it's a better functionality for data loading. Next slide, please. Moving on to task 2. As I mentioned, Magix is currently the go-to package for most of the ECMWF projects, and it's really a mature package. I mean, it provides various functionalities and various functions, such as you can directly select, instead of having to select latitude and longitude, you can just mention something like Eastern Europe or Central Europe, and it provides you with all these latitude longitude plots. And it's very much more mature than what we can expect with Matplotlib to plot this geographical plots. But when it comes to machine learning, it's better handled with Matplotlib. As I mentioned, this ROC curves, plume plots, Magix was not initially developed with like this machine learning functionality in mind. So that's why adding these functionalities in Magix can be one task. But at the same time, since Matplotlib is much more mature when we're going for machine learning things, it's better to see if we can just use Matplotlib with CliMetLab. So in the short term, we mainly wanted to go for integration of Matplotlib into CliMetLab and provide users with the functionality of using this graphs, which can be from Jupyter notebooks. And in the long term, we plan to have something like both the plots can be plotted with either Magix or Matplotlib. So this would be much helpful so that user can see if they are getting better performance, like better plots and with better functionality with either with Magix or with Matplotlib. So that's what we are trying to do here. We are adding both the drivers and trying to provide user with the option to select either of them. So that's a long-term goal. Since CliMetLab is in very much early development, we are currently just trying to see if Matplotlib can help with the machine learning plotting functionality. So next slide, please. So this is the current setup in CliMetLab. So we have this plotting functionality which calls the drivers API and which initially called this Magix API, and then we had this actions and plot figure classes. But with the new addition of Matplotlib, we have both. We have Magix as well as Matplotlib, which can help, like the user can select the driver. This is currently from the view of developer, and for user, it's you can just select either of the drivers. But currently, the Matplotlib driver code is not merged with the CliMetLab. As I mentioned, it's very much in early development. But once we have merged that, we'll be able to do this. We'll be able to have both, the users. Currently, this is the developer view, but from the user point of view, user will be having both the options to use either Magix or Matplotlib. And then the user can plot the training curve with Matplotlib and at the same time get the geographical plot with Magix. So that's the plan with this idea. Next slide, please. Yes. So here I'm adding mainly the few plots that I tried to recreate, which were, so if you look at the Magix homepage, you can see many examples, which are of these geographical plots, which are very well plotted with Magix. But what we tried here is to see if we can get similar plots with Matplotlib. So apart from providing something like machine learning training curves and all, we tried to see if we can get the geographical plots as well. So that's here I'll be presenting a few plots from that. So this is the basic plot, which is a hello world plot as it's presented in Magix tutorial. Next slide, please. Here I've used one of the files which is available in ECMWF repository, this data repository specifically, and this is the mean sea level pressure field. The colors are not really up to a level what we get in Magix, but it's still a good way to present, and at least we can see some things with Matplotlib. Next slide. This is the precipitation field. Again with Matplotlib, which we have in Magix tutorial, but in a much better way. Next slide. Again, now I've used some data to plot the contours, and which provides us the terrain over the world map. And this is again similar to what we get in Magix. Next slide. Now I've tried to get, so this is similar to the previous plot, but here I've tried to provide a shading to that. This is possible. All of these things are possible with this base map and Cartopy API, like these libraries, which are currently being developed in Python. But again, this is still in development and not as far as with what we get with Magix. Next slide, please. This is for the temperature shading, and again, this is quite similar to what we get in Magix. So it's this one is a good plot. Next slide, please. This is one of the things that I mentioned before as well. So when we are using Magix, we get this. You can just mention Eastern Europe or Central Europe, and you get this direct plot. But when I'm plotting it in Matplotlib, I have to specify the coordinates of for this latitude and longitude. And even with that, once we get that, and then we can have something like this river network across Europe. So this is also possible. So what I'm trying to show here is that many of the plots can also be plotted with matplotlib, which are mainly done with Magix, but still it's in early stages. We don't have this very user-friendly and good-looking outputs as we get with Magix. Next slide. This is again a Lambert projection, which we can get as well. Next slide. This is again now a cylindrical projection for Australia from in matplotlib. Next slide, please. Okay, so as I'm discussing this for like now with Magix and matplotlib, this is the next like the way forward. Matplotlib offers plotting functionality with basemap and Cartopia-like packages for geographical plotting, but as we have seen, Magix is still much superior for geographical plotting. But since the model training API is in development for CliMetLab, matplotlib will be highly effective when we are going for this curves we get with ML models. So that's the next step. Next slide, please. All right, so these were the mainly two tasks that I worked on, and there is another task that was supposed to be experimental, and we wanted to see if we can work on it, and this was just supposed to be exploratory work. And in this work, what we wanted to see is mainly if we can try to see how we can store this large data sets and how we can process them. So for small scale data sets, the conversion between different formats is simple, and there are many other APIs are available for that. But as I've shown here, so if you have an HCDF format data set, we can convert it into ZAR format simply with Xarray, and similarly for grid. But when we want to process large-scale data sets, it's not this simple. I mean, it can be done, but it's very a long process. If you try to go for data set which is say in GBs or in TBs, so it could take very, very long. And that's why we need some simple way to process that. And this is a much later work. I mean, this is not in plan for like the next few months at least. This could be once the CliMetLab is much mature, we can add this functionality of having processing this parallelly and adding this Xarray things. But as I mentioned, this is experimental thing. So next slide, please. Why we have this concerns of data storage. So we want to have multi-threaded parallel read and write. We want to avoid swapping in chunking strategies. So when the data is, like as I mentioned, in large size, we want to have chunks of the data so that we can have the data stored properly as well as access, faster access. So for that, we need to have good chunking strategies. Then we also want compression and CPU time required to uncompress or compress. We need to work on that as well. We need to have faster access to data. And we also want to check the performance on cloud storage, how it goes. So for all these, we need ZAR-like alternatives, which can help in efficient storage and handling with the help with Xarray. So this is still like some experimental things. Next slide. Okay, so as part of this ESoC, I mainly worked on first two tasks. And currently, I'm just starting with the third task, which would be I'll be continuing since the package is much more in development. And I'll be trying with multiple data sets and CPU clusters to see which strategies work better. Next step would be once we have enough development, we can merge the matplotlib driver development into main CliMetLab package. So as I mentioned, user can have these two packages that they can use for plotting. And we are also planning for further development and feature addition in CliMetLab package, like more drivers if needed, then caching mechanism for the data specific to machine learning projects, and a few more machine learning specific features. So these are the next steps that we have planned. Next slide, please. Okay, yes. So that's it from my side. This was a really great working with Florian and Varun. I learned a lot. I mean, this was, and it's fun to work in such a initial stage package. So I'll encourage people to join and contribute to this package so that we can move it forward. And yes, thank you for your time.
Thank you, Ashwin, for presenting your great work and your enhancements to CliMetLab. and thank you for your presentation now. So I have a question regarding, will you continue also being involved in the developments of CliMetLab?
Yes. So as I mentioned, it's still in very much it's in early development stage. So I'll be happy to continue my contribution to it. And as I mentioned, I want to merge this driver code that I've added. So I'll be working with my mentors for that.
Okay, great. So yeah, with this, I thank you again for being part of ECMWF Summer of Weather Code this year. It was a pleasure to have you. And thank you again for your time today. I would like, before we go on to the next presentation or to the next project, I would just to remind everyone who is joining us today, there is the opportunity to ask questions on Slido. So please go to slido.com and enter the hashtag ESOC 2021. And if you have any questions to the specific project or the participants of ESOC 2021, then please drop your question there. And now we move from machine learning to web visualizations, and the two last projects which we will present you this morning have a focus on web visualizations. And the first project was more on software development, so it was specifically also enhancing a visualization package called Blender to make it easier also to visualize meteorological and climate data. And so the project is called BlenderNC enhancements, and the project team is Tisham Dar, who is joining us today from Australia, but his team members are Gicini and Josue, and the three of them worked on the project BlenderNC enhancements together with the web development section at ECMWF. And with this, I would like to welcome Tisham yes, we look forward to seeing your results. Welcome, Tisham.
Thank you. I'm sharing my slides. I worked on this very recently, wanted to get some forecast data for the 2021 Atlantic season. So I was like going with very recent stuff. So I was very ambitious with the results I wanted to do. I did some last minute work, you will see, with public cloud infrastructure as well. So the results here are sort of focused on visualization rather than code quality improvements, which was something we were looking at as a part of the project as well, and we presented during the midterms. This particular one is more about the final data loading and the outputs, visualization outputs. So let's get into it. So when I started this project, I really love the planet. I am an environmentalist. I have not hugged the planet, but I've hugged a fair few trees. So there is this amazing music video where it's produced in a 3D graphics mode, where the musician has his avatar going and hugging the planet, and it's created in a commercial rendering package. And I wanted to create something, you know, that will let you do this with real data, add yourself to it, and have some fun with weather data, use it for storytelling as well as science communication. If you're a creative or a scientist, scientists have difficulty getting from the equations and the maths and the computing to telling the story about why the work is important. So Josue does amazing visualization work that sort of drew me to this stuff. I was working on this anyway. So yeah, it was a great start. So this is a nice song. I will not play it here, but sort of where we were going. So we're living in the real world. People are talking about the metaverse and things in the technology community. We are not in a metaverse. or I don't know. But ECMWF is all about simulations going forward in time, doing the reanalysis, going back in time, and tying it all together into a coherent picture of what the Earth has been through and what it will be in the short term, so on. So the aim was to cover as much ground as possible in supporting the GRIB format and visualizing that, loading data from it. We got to where we got to. We pushed hard. Josue pushed hard. I provided direction where I could. Gishin did a bunch of validation on stuff. Especially on the forecast side. So we'll go through some of the successes and learnings we have, and obviously a lot still to do. So we'll talk about that near the end. So one of the successes is after the code quality improvements and all of the sharpening the axe stuff, the loading is fine. We can chop up the GRIB and that's fine. So the BlenderNC is easy to install now. I struggled a bit to do it fresh on Windows, but that will be documented and any gotchas captured. There's support for ERA5 LAN. There is also support for forecast GRIB files. So that's good. So it basically is one step in our journey, getting it from the file to the RAM that Blender will use. And then it will get from the RAM, push it to the screen. So I have a short 2 minutes here on the data loading. So this is Blender for those. It's a notoriously complex interface to use. This is Blender 2.92. You basically click on a little folder icon, just look at the mess that's my file system, and then pick up a file. So I've got various files. Sylvie, our mentor, sent us some forecast data, thankfully, and ERA5 I got from the data dissemination portal. And you can see that the variables that are loaded into it. When you go through, and then I will just do a couple of different ones. So I have tested this with ERA5 land, and some forecast files. So in the interest of time, I'll share the slides after this. We'll just skip over this section of loading the different ones. I just included a full video here. So the next step, obviously, after you have pushed it from the disk to the memory of your visualizing engine, in this case Blender, the next step is to push it to the screen, to render it, to push it to even the files, to make a video. So that's sort of using the GPU renderer. So BlenderNC has this node system, modifiers. There's a lot you can do. We're still writing the advanced usage tutorial in the documentation. Josue probably is a better person to write it than myself. I use it at a very basic level. I provide coding best practices guidance and some of my knowledge of the file formats and such, and data scaling and all of those. So there has been a bit of documentation. Advanced usage has been partially documented, and then the ultimate things that has been discussed a few times in the previous presentations is scaling. So doing headless, which is without a screen, public cloud rendering, all of the world at very high resolution, long time series S, that sort of stuff is like visualization is involved there. So the visualization samples I will quickly go through are just the simplest possible example. Just one instance, one frame, one thing. A series, couple of time series of the past based on ERA5 land with a little bit of a story, and a bit of the future series in the Atlantic hurricane season of a particular hurricane, Peter, which was active recently. I chose the hurricane because it's named after a rock. A bunch of wind named after a rock sounded fun, so I chose that. So the instance frame is really easy. You should be able to get to do this in 5 minutes. You download your data, you are prepped, your BlenderNC is installed, you launch it, you load the data, and you essentially do something very simple. You press F12 once your data is loaded, and you get like a simple sphere, so that your data is loaded, you get something basic, simple, and a color bar saying this is the temperature in kelvins. Something very basic and simple if you have one instance. If you have a time series, you download the data, data is bigger, download time for, I think data prep time for me took like an hour, the download time took a fair bit, I left it running overnight. It was something about the past. I like names, I chose a hurricane, Dorian, the story of Dorian Gray, someone who always stays young, and the rendering of him, the painting ages. So I chose a fun name here as well. So chose Hurricane Dorian as the history, but Dorian Gray's story is not a fun story. It's yeah. Anyway, the Dorian story is like science communication story as well. The science was very politically incorrectly communicated during Dorian, and some of the probabilistic stuff that BlenderNC is currently missing in showing the envelope of the path needs to be implemented as well. One of the other things that needs to be implemented in BlenderNC and is one of our pillars of work to do is support for 4-dimensional fields. So this is what happened when I tried to render the data for Dorian I had downloaded very painstakingly. So yeah, we are not there yet, but you know, it's a learning exercise and continuous journey in getting things done. So the next one I wanted to do was go through a time series of the future using the ECMWF simulation outputs, forecast outputs. And this one is interesting because this is the current hurricane season, and the toll for the Atlantic hurricane season this year has been quite big. $55 billion US, and then around 150 lives. And the name of the hurricane is Peter, which comes from the Latin word Petrus. And it's basically the Earth acts as a big gravitationally coupled gear spinning the hurricane using the Coriolis forces. And that's quite interesting to see. Sylvie sent me the data just in time for me to prep this. I got this up. I'll play a little video of what happens when you use BlenderNC to quickly render one of the fields. It's a very slow video, and you can see the rendering on the globe. I haven't done any dramatic camera animations or anything, which Yosue is very good at doing. And if you have a Storytel board, you can build a lot on this, but already you can see some good shading and coloring and the potential of this, what this can become if you have a good story to tell. Yes, again, this is a very short video, so I'll just move on from this one. So the rest of the time, I spent time with several calls with Stefan and Sylvie, discussing the ECMWF weather cloud, how to take advantage of that for our project, how to enable a lot of others to use Blender on the ECMWF weather cloud to do this sort of interesting renders and tell the story, get better science communication, and sort of merge the outputs on the website with the inputs coming from the science side. So yeah, so like use the SSH and X Windows access. So create a render farm. So briefly, for a brief period in New Zealand, while all the big movies were being made, Lord of the Rings was being made, the biggest computer was not a weather simulation computer. It was the Weta Digital was the movie making computer in New Zealand. So movie making is a valid use of HPC systems. And Stefan has tried some of these, and there is currently sort of a gap in the X Windows support in the European Weather Cloud, which we are going to Stefan is going to look to address. So I tried something similar using the public cloud. Recently, Amazon Web Services has released a product called NiceGCV, which lets you run Blender remotely and get the display pumped out. So I had some learnings there. I was on a call with the NiceGCV HPC experts today in Singapore and in Australia, going through their solution, kicking its tires, we got to a stage where we agreed that this will be feasible, will be a great application of the public cloud to spin up Blender instances, create a render farm, render weather data for specific storytelling purposes for Australia, for ECMWF, anyone who has weather data. AWS is all about it. I got in touch with the AWS division, which does this through my work in HPC and WRF, running HPC clusters in AWS for that purpose. So the stage we got to was essentially, there are lots of fine-tuning things done. I had to actually first get access to a GPU machine. That took a few hours. Once, if you're ready and you have all of this parallel cluster stuff set up, nice GCV set up, it works really nicely. The learning is that you have to have all of those and an infrastructure team to do it. I can do all of these things for myself because of my personal experience. So you can get like a pretty big node with extra large node with a GPU from which you can send the display to yourself and see the results. The possibilities are essentially, there are ideas. There's a book I like by Ramiz Naam called The Infinite Resource. The possibilities are endless. As we continue to engage with ECMWF, get new ideas, put things together. Some of the ideas we have put down here, like wind vectors as hairs. Blender supports these hairs for characters. You can make the Earth wind vectors around those. More stuff around X-array, non-uniform grids. If the data gets too big, stream the data from the cloud or via the API. Any number of things is possible now that we have a good framework, good development flow, good mentorship, and access to the data. So the team, as Julia was saying, is pretty distributed, but weather affects us all. Gishini is in Kenya. I am in Adelaide. I'm not in Sydney. I'm in Adelaide, Australia. And Joshua has just gone back to Mexico before he starts his postdoc in France. So yeah, but the weather is a common theme that affects all of the planet. And yeah, I have a big blurb of the conclusion, but I just would say that, this has been a great experience. And I'm looking forward to the BlenderNC becoming as popular in the weather simulation visualization community as Blender has become in the mainstream 3D graphics community. Thank you for the opportunity.
Thank you, Tisham, for your great presentation and also sharing with us your great developments you provided to the BlenderNC community through the Summer ESoC project this year. So thanks a lot. You also already shared with us that you have endless possibilities to collaborate and also to enhance even your developments and to make Blender a stronger tool, I would say, in the weather and climate community. And we are quite excited to see what is yet to come. So thank you for joining us today and for also being part of, to you, Josre and Gicini, for being part of ECMWF Summer of Weather Code. It is a great pleasure to have your project and have you working on BlenderNC. And thanks for your time today.
No worries.
So I would like to now go to the next, or present the next project, and also the last project for the first part of today's virtual event. And the next project I want to present has the title Meeresvogel, which also is a project related to visualization. The project has been worked on by Catherine Schmidt, who is joining us today from France, close to the Atlantic. And she worked together with the development section on improving web visualizations. But I think she's much better in explaining what her project Meeresvogel is about. So Catherine, it's great to have you here today, and welcome.
Thank you, Julia. I can explain Meeresvogel. I, unfortunately, not being a native German speaker, can't pronounce it as well as you, but I'll have a go. So the aim of Project Meeresvogel is to explore what I call the missing middle in weather graphics. And that's to say that there are plenty of tools for doing weather graphics within the meteorological community for the meteorological community that do very sort of detailed and highly technical outputs. And then there's also, at the other end of the spectrum, the tools that are used for producing weather output to show the general public, say, by broadcasters. And I've found as somebody that often wants to tell stories that have a weather-related component, that there's not really much in between to help us make these graphics to tell our stories. So although both these types of systems, I'm not questioning the validity or the usefulness, they're all brilliant. I thought it'd be nice to have something more in the middle to work with. Next slide, please. But this got me wondering, so, you know, what kind of tools could I possibly make to allow people to make these kind of graphics without having to master the intricacies of a tool like METView, which again, METView is brilliant, I love it, but not everybody, especially people not involved in the meteorological community, have time to master it or the inclination to master it. Next slide, please. So who am I and why do I care about this and why do I think I'm well placed to do something about it? Professionally, I'm a web systems engineer and I have a passion for telling stories with data. I've done this for nearly 30 years. In a wide variety of domains, including artificial intelligence, arts, genomics, online gaming, finance, and of course, my favorite domain, meteorology. And I've worked with systems at both the extremes I've described, both at ECMWF and the BBC Weather Centre. And in the picture you can see me during my time at the Weather Centre. That was not broadcast, that was just something that we allowed the public to play around with when they did their tours at BBC. Next slide, please. Sorry. So also, I have a personal interest, or many would say obsession, with sailing, and in particular, solo ocean racing, which led me to depart my lovely colleagues at Shinfield Park in 2013 in order to attempt a 3,000-mile solo ocean race across the North Atlantic, which I eventually attempted in 2017 unsuccessfully, and I hope to complete successfully next year. This obsession also led me recently to move to the Atlantic coast of France, where I can more easily combine my personal and professional interests. Next slide, please. So the example I wanted to work with for my demos comes from an event which coincidentally, or maybe not entirely coincidentally, was happening just up the road from me when I moved here last November. And it's called the Vonde Globe race. It's a quadrennial, non-stop round the world solo yacht race that starts, like I said, in Les Sables d'Olonne. And the last edition, we had 33 skippers from 9 countries who spent between 80 and 120 days each alone sailing their 60-foot boats around the world as fast as they could. And just to kind of, if you can imagine it, they had to be in full race mode 24/7 for the entire time, never sleeping more than 20 minutes at a time, mentally having to, physically having to do the equivalent of, say, a marathon or maybe even 2 each day. And again, like I said, not being able to recover because they didn't get to sleep very much, eating terrible food, having to mentally make all the navigational decisions, which involve downloading lots of gribs and studying the weather forecasts to try to decide where to go. And then they also had to troubleshoot any problems that happened on the boat in electrical systems or mechanical systems. And then, as if that's not enough, the race rules this year added that each competitor was required to send back a certain number of audiovisual assets as they went around the world. So they actually had to make videos and in many cases edit them on board themselves and conduct interviews. And yeah, so it was just, they were a lot, but it was an absolutely fascinating event to watch. And that might explain how it built a fan base of 11 million worldwide. And in France, there were 193,000 pieces of media coverage during this event. Next slide, please. So the main source of information was the site's own tracker, and which was brilliant. And me and everyone I knew and 11 million other people were absolutely glued to this for, you know, morning to night for the entire 4 months of the race. And you could mouse over to see information, sort of instantaneous information about each boat. Well, kind of how fast they'd been going and things like that. If you could go to the next slide, you get a better view, sort of more zoomed in. Yeah, so sort of telling you how far that each boat has to go and how fast they've been going, and then a little snippet of information about the current conditions around the boat, so air temperature, water temperature, wind, and waves. And then, as you can see underneath, the chart was showing 10-meter wind. And this is all really great, but I felt like it was missing something because on the other side of the website, which I haven't shown, was the collection of audio visual. So you could go through, and every day there would be videos from lots of skippers and interviews and audio podcasts. And so in the end, at the time, it was quite fun and engrossing to be consuming all this, but it was quite divorced. You know, the human stories were quite divorced from kind of looking at the weather context on the chart. So I thought that I'd like to have a go at doing something better. So next slide, please. So my aim was to explore building a proof of concept demo with constructing some tools to help people create an enhanced race tracker using Google Earth. And when I say enhanced, the ways in which I tried to do this were by making better overlays, better mouse overs, links to the audiovisual content within the tracker itself, graphs incorporated into the presentation, and then finally fly-throughs. So I'm going to take each of these one at a time and show you what I did. So next slide, please. So like as I kind of alluded to, you know, the 10-meter wind is probably, you know, for people that are following the racing aspect, one of the most important things, because to win you need to go fast, and to go fast you need to find the wind. But for people that aren't so interested in the technical aspects of the racing, something like this, which is 2-meter temperature, kind of helps people relate kind of the human experience of being on the boat to you know what we understand. So kind of we could picture, you know, these poor boats having to go through the tropics, and where it got extremely hot and there was no shade, and you know, it was like an oven inside these carbon fiber boats. So this is kind of an interesting extra sort of enhancement, and it makes a layer that helps non-technical users sort of connect more to the experience of the skippers while looking at the track. And next slide, please. But for the sort of more esoteric sort of technical users, here's one that I built, which was an overview showing the Benjamin Fear Index. And this is something that is extremely interesting to me as somebody who's done a lot of ocean sailing and encountered quite scary sea state conditions. I learned about this from Peter Janssen, who was head of the Marine Aspects section, just around the time that I left the center. And I had the bad fortune to wander into an area of extreme sea state, and ended up losing my mast and nearly losing my boat to one of these. And when I talked about it with Peter afterwards, and he sort of went through, pulled up the charts from the archive, and he talked about the Benjamin Fear Index and how you know, it was likely that I had in fact encountered a freak wave, and that one way that might be, you know, that it would be interesting to sort of have more of a heads up about these sorts of phenomenon would be to look at this particular parameter. So it's interesting to me. I've found that even people I've talked to who work in ship routing are oftentimes not aware of this. I think it's something that deserves to have more exposure in the world of sort of ocean travel. But anyway, so this particular layer sort of shows the area of elevated freak wave risk as a sort of darker red. I didn't choose this. This was the ECMWF default styling for this parameter. I think it's quite apt because it makes it look a bit like stab wound, which, yeah, it can hurt to go through these kind of areas. But in this particular screen grab from Google Earth, you can see the two leading boats who are just charging through an area of quite elevated sea state and elevated risk of rogue waves. Next slide, please. And although I've turned off that overlay, this is kind of the same view without the overlay, where I've moused over a link to a video that was sort of published on that day by Thomas Royan, who was the second boat that was going through the really dark area of the rogue wave risk. And surprise, surprise, we have him on the video saying that it's the sea state that's been particularly nasty today. And elsewhere in the video, he talked about it being like a cauldron. So I feel like it kind of helps people to understand, you know, when they look at the charts of something, to be able to immediately click and get sort of testimony from the skippers or demonstrations of sort of what things are looking like to them at that point. Really adds to the engagement. And likewise, next slide, please. You can, is that the next slide? Okay, thank you. I added, I thought about the parameters that might be interested to have access to in the mouse over. So in this case, we mouse over linked out on that day, and you see, lo and behold, the Benjamin Fear Index is up at 0.6, and the significant wave height is over 4 meters. And keep in mind that when you see that significant wave height, 4 meters, what that actually is saying is you can expect regularly to see waves of up to double that, possibly more. So these are definitely, quite intimidating things to be encountering on a small boat out in the middle of the ocean. So again, these the parameters that you choose to show on the mouse overs, can be changed to suit the audience. So this, of course, will be something that the diehard fans will be interested in, but in other cases, you might want to just show, like the main tracker does, temperature, air temperature, sea temperature, for a less sophisticated audience, and not overwhelm them with lots of data. Next slide, please. Fly-throughs I did not get to do, but I'm really excited to figure this out and make some to share with people soon. So next slide. And finally, graphs. So I ended up using GeoPoints format to collect files for each boat's track for each parameter. And the lovely thing about that is MapView makes it very easy to make graphs of these. So here's one case where I'm showing, and this could be embedded into the presentation, of course. But I found this one really fascinating. It's the mean sea level pressure, which is kind of a proxy for how fast a boat can go, because areas of low pressure tend to have higher winds. So the really competitive boats will really see how close they can get to the center of depression to get an extra boost. But it's always a balancing act between sort of how strong a wind you want to be in versus how difficult it is to manage the boat and get rest and things while in these stronger conditions. But this is showing the track mean sea level trace for pressure trace for the first boat to finish and the last boat to finish. And I think pretty much anybody can look at this and see that it's essentially the same kind of shape of curve, but in one case it's been compressed in that the first boat kind of got through the course faster, but it kind of shows that all of the boats are going around the world, and so they're encountering more or less the same types of conditions, just at kind of different rates. And you can see here, in addition to it being faster, the red boat was sort of, you can see the valleys are deeper, and that's kind of indicative of his appetite for risk, that he was more willing to go closer to the centers of the lows. And also generally, the values of his pressure values are lower, sort of in general, than the blue ones. Who, so in this case, the competitor was a Finnish guy named Ari Husela, who's an amateur racer. He's an airline pilot, and so he has a very kind of measured, conservative, by his training and out of habit, a very conservative approach to risk. So you can see that he wasn't sort of going for it, sort of sailing into the middle of the lows constantly, like the first boat. Next slide, please. And here you have, again, two boats, but this is the first boat to finish and the third boat to finish. And it's just, I look at this and I just think it's amazing how similar they are. And it's kind of, to me, saying that these two skippers were very close as they raced around the course, and had very similar risk appetites, and that they, kind of went for the lows very much in a similar fashion. Although you can see that the red one, his lows in a number of cases are that much bit lower, which I think is what helped him get to the finish faster. And there are a couple interesting divergences in this graph, which I think tell a really interesting story. The first is around the end of November, when one of the competitors, Kevin Escoffier, was in some strong conditions, and his boat literally folded in half and sank, and he went into his life raft. So a number of the competitors who were nearby were diverted to go search for him in his life raft. And the blue boat, Metrocock, was one of them. So you can see at that point, early December, where suddenly he goes off into a more high pressure area, and that's him kind of taking his foot off the throttle and going to look for Kevin. But he then sort of managed to catch up really well after they luckily found Kevin, and kind of was battling it out with the red boat for the rest of the course. And at the very end, you can see where he goes, he's kind of desperate to try to get ahead. And you can see him sort of going for it a bit, taking more risks. But he ended up, if you look on the tracker, he ended up going a bit north, sort of off the path, but in search of stronger wind to try to get ahead of the leader. And what ended up happening was, although the blue boat Metrocock finished third, an international jury sort of awarded compensation for the time that he'd taken out to help in the search for Kevin Escoffier, and that time was sort of agreed soon after the incident. So throughout the race, he knew that he had this extra time that would get deducted from his finish, and that allowed him to win the race overall. So although he didn't finish first, he was the winner of this edition of the Vonde Globe. Next slide. And finally, this is possibly the most exciting slide in my opinion, but disguised as the most boring. It's a spreadsheet where, and this is one of the nice things that using the GeoPoints format allows, it's the competitors ranked by the percentage of time that they spent in the areas of low pressure under the 5th percentile and above. So I sort of looked at all of the pressure readings, found the 5% lowest ones, and then figured out how many of those belong to each competitor, and so normalized it by how long they actually took to do the race. And what ended up happening was I noticed that the top 10 finishers were the ones that were the sort of top 11, had the top 11 percentages of time spent in these relatively low pressure areas. And there's just one, Louis Burton, who was third, who got kind of bumped out of the top 10 spot by a boat who unfortunately didn't finish, and that was Isabel Josh on MACF, who had keel problems just after she came around Cape Horn. And what this says to me is that, I mean, it's really especially gutting for her, because I think this is kind of showing that she had a real potential to finish very well, possibly as well as fifth had she finished the race. But unfortunately, she was knocked out. But I just found this correlation extremely interesting, and it really sort of popped out at me. So I thought I'd share it. So finally, future plans. I'm going to finish the demo, so do some fly-throughs and share it with people who might be interested, collect feedback, and to continue working on it and making it better. I need to document my code and make it easier for others. So at the moment, I kind of have descriptions of what I've done, how I've prepared all the data, how I've generated all the assets that could be followed by somebody, but it needs to be sort of written up more clearly. And I'd like to consider using other output formats such as Leaflet.js, or doing some demonstrations that are things not to do with sailing, something based on the land, perhaps. Next slide. And finally, I just wanted to say thanks. I couldn't have done this without the support of ECMWF, in particular the ESoWC team, and my mentors, Stefan Stiemann and Ian Russell, and the MetView and Magix teams who've made these great tools, and especially the reanalysis team who've created Era 5, which is amazing, and they don't get enough praise, I don't think, or credit for this amazing resource they've created for the world. Also, I'd like to thank the teams responsible for the Climate Data Store and the CDS API, which made it really easy to get the data. And then also Peter Janssen and the other members of the Marine Aspects section who put up with all my questions over the years about sea state. And then also just to thank Kevin Salu at Regadata, who made it a lot easier for me to get the track coordinates for the boats, which on the official site are kind of buried in a weirdly formatted Excel. So thanks, Kevin, for saving me a lot of time, and the developers of the JQ utility. And also, I forgot to put in here, but especially thank you to Florian, who has shown amazing leadership and encouraging ECMWF to be more innovative and open. And I think that's a really great development. So thanks.
Catherine, thank you so much for your great presentation and also sharing your project results with us. I find it always amazing how you can tell stories, and I was amazed that just based on a mean sea level pressure graph, with your work you can now infer specific characteristics of different sailors, whether they are more risk takers or more risk adverse. So thank you so much. I have one question. So once you finalized your developments and you made a documentation, will this then also be available for the public
Yes.
to be? Yes.
Yeah, and I apologize for not having everything up on GitHub, but I was trying to put it up and I found it was interfering with my my Zoom. So I will do that later this afternoon. So the code that I've done so far will be on the Meeresvogel ESoWC Git repository later today.
Okay, perfect. Thank you so much. And again, also thank you for being part of ESoWC ECMWF Summer of Weather Code this year. It's been great to have you and also your project, and thanks for your time today.
Thank you.
So we are now at the end of part 2 of the virtual Final ESoWC Day 2021. We are at the end of part 1, I apologize. So there is a part 2 coming this afternoon, which will start at 1:30 British Summer Time. So we will have a bit of lunchtime now, but then we resume at 1:30 British Summer Time with another 4 amazing projects and project teams keen and just waiting on presenting you their results and project outcomes. This morning, we had already a full basket of what open source development can look like, and also what innovation in climate and meteorology can look like. From software development, enhancing a Python package, to a more applied machine learning application, to creating a user dashboard, or projects more relating to visualization and also telling the story from the past, but also where our where the Earth state is heading to. And so you can be excited also for part 2 this afternoon. The projects, they will be as excited or as exciting as this morning. And we hope that we can also welcome you again this afternoon. So again, the same link. So please go to the ESoWC project website. And there we will have the live stream. If you have questions, feel free to go to slido.com and enter the hashtag ESoC 2021. And we can then pass on the questions to the developers. And thank you for joining us this morning. And then I hope to see many of you again this afternoon. Again, at 1:30 British Summer Time, we will resume with part 2 of the final ESoC Day 2021. Thank you and hope to see you later.